Hey guys, welcome to week 6 or 5. It's weird, but we're synced everything. So today's meeting is brought to you by our sponsors. A few more are coming, so expect that next week. But also Wegmans has signed on as a gold sponsor for us, so we'll get food during our sec. We'll finally be fed. Yeah. So there is no RC3 sign-in this week. We're gonna try something with just the RC3 sign-in flag, which is RC3 and then curly braces, and then SWEN331, where the E in SWEN is a 3. So yeah, if you guys want to write that down or do it on the site. I don't think it's on the site yet, right? It is? Okay, do that on the site. Yeah, definitely we've heard a few complaints about how annoying it is to write your name and enter in the same information every time, so do that. It's important because sponsors want to know you're actually coming and we're not just using their money. Otherwise, it's also Ohan's birthday, so when you see him today, just make sure to say happy birthday or sing happy birthday.
Where is he hiding?
What?
Where is he hiding? What'd you do to him?
I don't know.
Breakfast.
Yeah.
What'd you do to him?
Yeah. But anyway, welcome back. Anyone new this week? No? Okay. Well, hey. All right. I'll come say hi later. But otherwise, mingle later. Answers coming back. We promise. Eventually. Also, no stupid questions. That's a channel in Slack. If you have any questions, it's a safe space, judgment-free zone for you to ask anything you want. You can also ask anonymously at ask@rct.club. Also, as most of you guys should know, IRSEC is April 21st, and B-Sides is the 13th and the 14th. The 13th is training day, the 14th is the actual conference. If you don't think you'll be able to pay, yes.
Sorry, continue. I didn't think you were going to comment right away.
No, it's fine. What?
What's the flag?
It's RC3 and then SWEN331, where there's an underscore underneath, between the words, and the E is 3.
Cool,
but,
thanks.
Yeah.
Sorry.
No problem. Besides the 13th is training day, the 14th is the actual conference. If you don't think you can make the actual conference because of some financial issues, come talk to me, come talk to anyone at eBoard. We'll make sure you're able to go. Otherwise, interest groups is Owen here. Owen? Okay, how's that going?
Pretty good. We've got like a few people who did the survey, but if you haven't done it already and you want to join Riot, make sure you fill out the type of form I can figure out when's a good meeting.
Word. Yeah, definitely fill that out. I think it's a really cool idea. RC3 will definitely buy you guys IoT things at hack. I think Guardians of the Network had their second meeting yesterday, so they're an official interest group. So yay! Otherwise, I don't think is Brad here. Is anything going on with that?
No, because midterm's week.
Word. Okay. Yeah, but if you're interested in starting an interest group, what that is basically you have a topic you're interested in, you want to deep dive into it, you can start a RC3 interest group and get a collective of people and just kind of do things together. And RC3 will try to provide you as many resources as we can with our sponsors and our just money or whatever thing that we can actually provide you with. There's also a special projects fund with the AWS grant. If you have a project that you want to explore, come talk to me or anyone at eBoard. You guys go through like a grant request and we'll give you AWS money to go do whatever you need to do. Yeah.
I've done 3 already. It's a pretty easy process.
Yeah, Ben's stolen like $1,000 from us. So yeah.
For research.
For research. Yeah. But that being said, we also have like another 8,000 left, so please come take it if we can't spend it all. Otherwise, those are our links. If you're not on the mailing list, go add yourself to the mailing list. For those who want to see what the YouTube is and find it really hard to find, we go to youtube.rc3.club. That should direct to our YouTube channel. Smash that subscribe button. Otherwise, anything we teach here is, of course, for educational purposes only. Don't be dumb. Don't do bad things or bad things happen to you. I won't stay up here and take your time any longer. So, yes. We have a guest speaker, Andy Meneely. He's the professor of SWEN331, which is Engineering of Secure Software, and also a teacher of other things. But yeah, you want to come introduce yourself?
Hey everybody.
Hi.
Hi. You don't need to clap at the beginning. Trust me, if you knew what was coming, you wouldn't clap. I'm just kidding. I'm just kidding. I actually don't have HDMI. I didn't check that.
You have a VGA.
I know, I'm old school. I have my mini. Or do we switch it from here?
Let's
Can we do that? Yeah, that should work. No, that won't work. That would work there.
We don't have a VGA cable. Hey, what do we do if the person doesn't have HDMI.
I think you can do this. And then switch the source to that.
Yeah, but then we can't stream it. Is the sad
Oh, but you
part.
can't stream it.
Yeah,
Oh,
that's what-
right. Okay.
Mhm.
I'm sorry, I didn't think of that. Tell you what. Do you have? So is everything working on yours?
Yeah.
Okay. So I'll just run it off of yours, and I can do everything. Do you have an SSH console? I mean, surely a CSEC major has
That's a
PuTTY.
good question.
Oh my god. Yeah. You terminal, right?
I mean, it's locked, so you can't really do anything.
Oh, okay. Sorry. Here you go.
Okay. So I will switch away from that. So you switch back to HDMI, or how do you guys do this?
It's always an
It always is an adventure. It's why I hate computers. There we go.
maybe.
Maybe? That's what it should be. Yep. Issue. Not selected.
That's my web homework.
I give it a C minus.
Too real.
Too soon? Too soon?
Yeah.
Oh, fine. I give it an A plus. It's all subjective anyway.
Maybe.
You got something? No. It's still web homework. Oh, this seems pretty interesting too.
Yeah, I mean, we can grade your web homework today if you like. I mean, I'm fine with that. Terminal, and then I'll use your browser as well. Do you have PowerPoint somewhere on yours?
I do not have PowerPoint.
All right, let's see how this goes.
Yeah.
Oh, you're in Linux.
Yeah.
Yeah, I thought they were compatible with everything. In retrospect, I really should make all my slides in PDF, so,
All right.
but I haven't. That's
Slides are in all in one tab.
No, I don't. Okay. So so one of the things I have going today. All right. I hate LaTeX. I'm just gonna start there. So
You can just.
one of the things that I love about LaTeX is that it is supposed to be like for programmers, where you like program your documents and everything. You're supposed to have a nice separation between semantics and markup. Not so much. That's not what LaTeX actually is. It's a hot mess.
All right. Browser, Alt Tab, back to the
Okay.
terminal.
Sounds good.
Cool. All right.
Okay, so what I'm going to do, okay, hey everybody. So this is going to be Swen-331. And so my name is Andy Meneely, and I'm an associate professor of software engineering. I'm also actually, I'm a member of the Center for Cybersecurity and a extended faculty member to the CSEC department. So, and my dissertation and my area is in how to engineer secure software. And so I like to sit between these two disciplines. And I kind of see myself as kind of a software engineer who fell in love with security. So let me start with how I got there. So when I was in when I was in college, I hated software engineering. I was at home making stuff. I was always coding stuff. I was always making. I was into AI. I was into genetic algorithms and fractals and things like that. And I was doing math stuff. And then when I got to grad school, and this SE course that I took was awful. It just felt really bureaucratic and really I felt like they did UML all day. And in retrospect, that SE course was taught really poorly. And then I went to graduate school and I met the software engineering people, and they were my tribe. They were makers. They were, that wasn't a thing back then. I mean, that word wasn't, the branding wasn't there in terms of maker, but like that's really what they were. They were always like just making stuff. They're interested in doing things well and doing things right, and but they were still getting things done. And that's what I loved. And so then I found out that they were software engineers. So I joined that group. And when I joined that group, I had a math background, and so they put me on some projects of developing software metrics, and in particular, how to measure metrics of human factors. How do software engineers work with each other? And so I started doing that, and I was using those metrics to predict bugs. And so we would say like, look, files that were worked on by people by themselves would be a lot more likely to have a bug. And then in early 2009, there was Obama became president, and the first thing that he did when he was in office was he did this stimulus package. And one of the things in the stimulus package was funding for U.S. PhD students to work on cybersecurity. And so at the time, that money trickled down to my group, and my advisor was like, Andy, we have this money, can you kind of pivot a little bit to security? And I was like, I'm not a security guy, I don't really want to get into crypto, I don't really want to get into, I'm not really into that stuff, right? And the security people, that I always knew were always like a really paranoid bunch. And I didn't want to live in that paranoia. I wanted to live in the world of building things, and so I didn't want the wet blankets of the security people. So, but my advisor said, you don't really need to be a security expert to do this work. And she used the phrase, just swap out the Y variable. So instead of doing number of bugs, try to predict number of vulnerabilities, and that was it. And I found immediately that all my models fell flat. The metrics that are correlated with bugs were not correlated with vulnerabilities, and I wanted to know why. So I started looking at vulnerabilities. I just went into the Linux kernel, went into their change logs. Linux kernel's in C. I knew C. I took an OS course when I was an undergrad. I kind of knew this stuff. So I just went in and looked at vulnerabilities, and I was expecting to not understand them at all. And in fact, I identified with the developers deeply. I was seeing really simple coding mistakes that anyone could have made, that anyone could have missed. I was seeing, off by one errors, and ooh, they miscalculated the memory buffer size because they did this thing. Oh, you can't assume that this thing is 32-bit, and and I just fell in love with the mistakes that people were making, and I didn't look at them as like, oh my goodness, these people are idiots, these people writing the Linux kernel are idiots, because I know that they're not. I was like, oh, that could be me. And how do we actually prevent these things? Because they're so few and far between, and yet they're devastating, right? This was back in 2008, 2009, and we started to really care about security then, the software engineering community, but we were really the last community to really care about security. And so a lot of our papers at the time were not about security, and that's drastically changed. And that's actually partly, you see it in the news. You see this stuff, vulnerabilities constantly being found. We have the best vulnerability branding now. I mean, now all the good vulnerabilities have T-shirts and stuff. So it's become a much bigger thing. So that's how I got into this. And I've never really left. And so I've been in this research field now. So I've been at RIT, this is my 7th year, and then I did a PhD for 5 years, so that was, so it's like, what, 13 years, 12 years that I've been studying this, and I still love reading change logs and looking at vulnerabilities, looking at real historical vulnerabilities, and learning about them. When I came to RIT, they asked me an interview question, if you could introduce one course into our curriculum, the software engineering curriculum, what would it be? I said security. And they were like, great, we actually have been looking for someone to do that. And I didn't even know that. So it was just a match made in heaven. So I got here, my first year here. I had a lot of energy when I got here, so I developed this course. So this course is a required course for all SE majors. And first of all, that's the line that should get applause. Yeah. because one thing that SE majors need to know is that security is not just something that a hobbyist does. It's not something that those those crazy second floor students do. It's a responsibility that we all have. It's the software that you write is no longer just a fun thing that people have. That was software in the 90s. Now we live in a digital society. Most of the software that you're going to write as an engineer has real life consequences. It's going to be, I mean, I can't even believe that we're talking about computers running cars. Like, I don't know. I don't want that. But at the same time, that's where we're headed. So, okay, so then this course is required, which means that everybody who doesn't want to learn about security is still going to learn about security. But that also means that the SCE majors who take this, it needs to speak their language. And so one thing that I like to do, and one of the reasons that I like to come here, I came here last year and I'm excited to be back here again, is to talk about the way that I talk about security to SE majors. And why, actually, a number of CSEC majors do take this. Sean is taking 331 right now. How'd you do on the exam, Sean? How do you think you did?
I don't know, you tell me.
It was a tough exam, right? Usually the first one people find really tough.
It wasn't the best.
It wasn't the best? Yeah. It's actually a hard class. My goal is to make it as hard as possible while still being fair. Like, I'm not trying to trick anybody, but I'm trying to show you that security is hard and that you need to care about it. And so if nothing else, if I inspire you to want to research your security problems and I make you a little bit paranoid, a healthy amount of paranoid, then you're in a good position. On multiple occasions, I've had alumni take this students take this course, and then within a year or two of going into industry, they have found zero-day vulnerabilities. There was a student who I can't name, but I'll say that it was Microsoft, because tons of SE majors go to Microsoft, so that doesn't really narrow it down. And within 6 months, he found a vulnerability in a product at Microsoft. It was a zero-day. It was a really big deal internally. And he got promoted as a result of it, and he got just got basically called into vulnerability discussions all the time after being at Microsoft for only a few months. And he came back and completely attributed to this class. He never would have thought about security before this class. So those kinds of stories are what I'm shooting for. Engineers who would have gone on building their cool stuff, but then are now thinking about security. Which is why, I see CSEC students as the race car drivers. You guys are the future pen testers. You're the sysadmins. You're the security analysts. You're the big guns that people call in for the really big and difficult problems. The software engineers need to be able to talk to you, and they need to be able to understand what you're saying when you get there. And we need to teach CSEC students how to communicate, but we also need to teach SE students how to begin that communication as well. So when a security consultant walks into the room and starts going on about cross-site request forgery, an SE student will know what that is. Maybe, hopefully, if we did our job right. Okay, so I'm going to see. I don't think I have some slides. We will see what happens. I don't think it'll work, but I'm going to try anyway. Come on. LibreOffice. Okay. All right, Linux. All right, Linux. I'm down with that. So what I have planned for today, how much time do we want to do?
You could still 120.
120? Perfect. Yeah.
You can go longer.
Okay. So I have a few things that I want to kind of talk about and show you a little bit about the class. I have some code level stuff that I can show you. People's favorite part of that class is this thing called Vulnerability of the Day, where we talk about code level vulnerabilities and some actual coding mistakes. So SQL injection is one day, and cross-site scripting is another day, and buffer overflow, and today was log overflow. Earlier this week was path traversal, and I have a list of about 20 of them or so. They all come with some sort of demo. The web application ones I won't be able to do because it's on that's on my computer, but most of the other ones I'll be able to do. Most of them are just command line. That's all open source. You're free to go there. If you want to see the slides that I'm looking at now, you can go to www.se.rit.edu, and then ~swen-331. We can put that up if somebody wants to do that, but we'll send it out afterward. You are welcome to look at these slides, steal them, take them other places. I've had a number of colleagues actually steal them and use them in their own courses. There's a guy in Germany who uses this stuff, someone at Carnegie Mellon. So, yeah, okay. So I'm going to kind of jump around to a couple of interesting parts of the slides, and then I will put up a couple of either mini rants or a vulnerability of the day, and we'll kind of do a request kind of thing. That way we can kind of keep it fresh and keep it interactive. So one of the key things that we talk about in 331 is the word vulnerability, and the word vulnerability is a bug. It is a bug with security consequences. And this kind of goes back to my initial, for me, when I thought of a vulnerability as some far off thing, but when I first saw it, I realized, oh, it's just a bug. I know bugs. As an engineer, I know bugs. That's my language. And so, so that's really what we focus on, is we focus on reducing vulnerabilities. A lot of times when I look at what CSEC people are doing, they're coming up with better intrusion detection systems. They're coming up with better antivirus. They're coming up with operating system designs. You're coming up with canary bits in the compiler, all kinds of interesting things. And all of those are great, and let's keep doing that. But a lot of times they assume that the code is vulnerable. And so they are a secondary defense. Not to diminish it, but it is a secondary layer of defense. That's just the layer that you work at. The real problem is us. The real problem are the engineers who made a mistake in the first place. So, and so we talk about the difference between a vulnerability and an exploit and a threat. And an exploit is, and you guys know this word, that's the actual code that, or the string that gets uploaded to the website, or that is the actual payload that a virus will inject somewhere, or something like that. And then we talk about threats, and actually one thing I want to talk about that I don't think I talked about last year, and maybe it would be a good idea to cover it this year, is this practice called threat modeling. And that is a place where you can talk about the design of your system while talking about different kinds of exploits. So I'll talk about that in a moment. So these are the kinds of things. These are the slides from it. Software security is not a myth but a reality. It's not an arcane black art. For me, approaching security as kind of a software engineer first was I kind of felt like the typical security person was like an expert on compilers and an expert on operating systems and an expert on all the protocols, and like they can just speak TCP when they want to, and like and because I didn't want to do those things, I would never learn security, and I disagree with that so much now. At the same time, with all of the mistakes that I see in vulnerabilities, I also am optimistic. I know that that when security people, a lot of times they will, because their business is making people secure, they have a way of kind of using fear to sell things, fear mongering. And it's actually not as, I actually think that we actually can be a lot better, and I think that we can get to a point where vulnerabilities are rare enough that we don't hear about them in the news as often as we do now. Or we don't, question the legitimacy of U.S. presidential elections. That would be nice. So the other thing is that I'm a bigger fan of secure software, software that has the property of being secure inside and out. And I like that more than bolting on security software on top. And like, yeah, okay, let's use the tools, let's use the right tools for the job, and let's use containers and virtualization, and let's do those things. But let's not forget, let's not use them as excuses to just ignore the security inside of our system. It's not just for mathematicians. It's amazing to me how many SE students think I can always tell a student who hasn't been studying and hasn't been coming to class when they say just encrypt everything. And we actually don't get to crypto until another 2 weeks or so in the class, and I take about 2 weeks on crypto in the class. And it is not any of the math or nuts and bolts of crypto. It is more about like, what is public key, what is private key, what are hashes, that kind of thing. How do you use this stuff instead of how do you change it? But I also like to use the analogy of a house, where if you have somebody break into your house, and because you left the window open in your house, do you blame the lock? Do you go for a lock that is more and more pick-proof? No, I mean, like, they didn't get in through the lock. That lock was secure enough for them so they didn't try to get in. They got in through the open window that you should have closed. Likewise, same with networking. It's not just a problem for networking. If somebody breaks into your house because you left the window open, do you blame the roads? Like, do we need to rewire the roads so that you're on a cul-de-sac or something? No, like that's a huge change for a very simple problem. Just close the window and find the open window and close the window. And so while I appreciate networking and mathematical solutions to things, there are many of them where I go, that is too complicated. SQL injection, easy to find, easy to fix, easy to eliminate. We don't need so many of these crazy solutions to make it better. It's just go and fix it. Just tell people about it, go and fix it. Show them how to properly use a prepared statement, and the problem is gone. A lot of times we try to engineer extra solutions on it. And then the last thing I think students find really useful is this third bullet here. I always see this come back on exams, is a vulnerability, or a vulnerability is a hidden feature for attackers. That's another way to think about it. It's an unintended feature, right? If I'm able to so in the early days of Amazon.com, back when they were a startup, and I know it's weird to think about Amazon.com as a startup, but they were at one point, they had a bug in their system where if you put a negative value in the quantity field of a certain product, it would give you a refund. That is an awesome bug. I love that. Because I can picture exactly how they did that, right? So like if you have your accounting system, and if the accounting system is negative, then that means you're getting a refund. If it's positive, like that's a really cool. There are no if statements. I understand how that works, except that nobody thought about what if somebody puts in a negative number into the quantity field, right? That's the kind of problem that could never be found by a static analysis tool. It could never be found. It is entirely domain specific. The meaning of a negative number, that this thing should not ever be negative is kind of a weird thing. And by the way, if even if you did, switch to an unsigned int, if you did a negative number, it would probably wrap around. You'd have an integer overflow problem, and you'd be buying, 6 billion, things. But those kinds of things. That is a hidden feature, right? If I put a negative number and I get a refund, that's a hidden feature that was unintended. And when you think about it that way, that can be really useful. Okay, so that's how we talk about security. That's kind of an intro thing. Let me talk a little bit about threat modeling, and then I'll go to the kind of improvisational part of this talk. So, threat modeling. Let's see, F5. Yes, hey, that worked. So threat modeling. So the way the software engineers think about the world is they think about the software development lifecycle. Okay, I know we love our buzzwords, and I'm sorry, but like sometimes you just got to speak our language. So lifecycle. When you try to define what the system is, we're talking about requirements. If you are talking about how you're going to do it, that's design. If you're talking about doing it actually, that is implementation. If you're talking about how you're going to ensure that it works, that's quality assurance or testing. And then maintenance is what do you do after you deliver it. One of the places that we find that engineering secure software as a set of practices, what we do is we integrate a different practice in each one of those development life cycles. This one is the part for design. So when you want to talk about how do you secure your system at a design level without thinking about negative numbers in quantity field, if that's a coding problem, how do you think about the larger design problems in your system? This is where you don't realize that you need to implement role-based access control, or this is where you realize the way you're trying to deduplicate files means that people can spoof other users, or what happens if somebody spoofs this thing and you can get in. This is where you start thinking about the system in terms of its networking, but not just networking, but by how the data actually flows. So the threat modeling is based on this really useful acronym called STRIDE. And so, Sean, how did you do on this question on the exam? Did you get the STRIDE question?
He did it. I actually forgot.
Oh, you forgot it. Okay. All right. We can do better. I was actually surprised that how many people missed this one, and I always say it in class going, I'm going to quiz this. It's going to be on the final, too. I'm telling you right now. So what does STRIDE stand for? And so you guys probably know CIA, right? Confidentiality, integrity, availability. That is the other kind of acronym. And I find CIA to be useful. I find STRIDE to be an even more useful acronym. And I honestly can't think of any kind of attack that doesn't fit inside of STRIDE. And so these are classes of attacks. Okay. So you actually have probably heard all these words, but here we go. S, spoofing. Okay. This is where you act like you're somebody else, right? This is where this is as simple as stealing my password, but it could also be session hijacking. This is where the system cannot authenticate you. Tampering. I'm able to modify something that I couldn't, and so that's saying that is kind of like I'm able to modify my own grade, or I'm able to modify somebody else's grade. Tampering also involves usually arbitrary code execution because you are violating the integrity of the system. Repudiation is the one that everybody gets confused on. I have a whole slide devoted to it later. You guys might cover this on your own. You might hear it as non-repudiation, which I find to be really confusing. I hate putting nons in front of things. Just say repudiation. But repudiation is where it is a violation of the history. And I can explain that more if you want to hear my explanation. But another key word for that is the word provenance. So, information disclosure. So that is what you think it is. There's something that it needs to be held private, and it is then exposed. So that is another kind of attack that you can see. And what is difficult about information disclosure is we often think of it as like, oh, tampering must be really bad because that's that's write access, and information disclosure is getting read access. That's not nearly as bad. But the thing is that like tampering is often something that can be reversed or can be made right. You can untamper things in many cases. But information disclosure, you just can't unring that bell. If you think about a healthcare system where you have somebody who has an AIDS diagnosis and that gets out, you can't change that happened, right? You can't go back. And so information disclosure is a very bad thing. Denial of service, okay, you've heard that before. That's what the D stands for. And E is elevation of privilege, or I also hear escalation of privilege. The key thing here is that, the key thing here is that STRIDE is a lot like CIA, only it fleshes that out a little bit more. Really, TRID is CIA, and then the S and the E are their own thing. So tampering and repudiation are really integrity. Looks like we have a UTF-8 problem where the arrow is not supported. Thanks, Linux. That's an arrow there. Information disclosure is confidentiality, denial of services availability. That makes sense. But then what spoofing and elevation of privilege are is they're violating authentication and they're violating authorization. And so again, knowing the difference between authentication and authorization. To CSEC majors, you might not think about how these are very different things, but to an engineer, these are very different designs, right? So authentication is, that's your passwords, that's your OAuth and things like that. It is usually one system, right? And so if you want to secure that, you secure that. Authorization is about where can people go, and that is not usually one system. That is how you configure the whole thing. So you might have role-based access control, But then how do you get the right permissions for the right situations? And that is what we call a cross-cutting concern. And so I think separating those out can be a really useful thing. Real quick, what we do in threat modeling is we create these diagrams. I know I just said that. Oh, software engineering feels like it's all UML all the time. Technically, this isn't UML, but it is a diagram. But you make these diagrams, and then from the diagram, you use a tool, which is the Microsoft Threat Modeling tool, to generate these threats. And what it does some really rudimentary natural language generation, where it gives you ideas on how the system is going to be broken into using your threat model. And so you can kind of say, like, this thing, my mobile app is talking to a file system on the phone, but then it is also making a network call to this other thing. And so what happens if somebody spoofs the network call to the server? What can that happen? And so it applies stride to every part of that diagram. And you define your trust boundaries, and you define all kinds of things. So I find it to be a very useful tool. If you kind of know how to use it, it definitely takes some training on how to use it. And so we spend a bit of time in there. And we'll see how this semester's students did on this. The take-home portion is due next week, Wednesday, so we'll see. But usually, the last couple of years, I think we've figured out how to teach this technique, and I think students usually do pretty well. So, okay. So, that is a little taste of what we're doing, and I apologize that I don't have my full schedule up here. Because I wanted to make some changes, and so I haven't actually revealed the rest of it. I suppose if you really wanted to see it, you could do view source and look at my HTML. But because I've just commented it out. We do so we do crypto for about 2 weeks. We talk about security managers, Java, in particular the Java security manager. That's a really interesting thing. We do insider threat. That's a fun one. Where we talk about what happens when people on the inside become evil. We have, at the end of the semester, we have a review game that is half D&D and half Dwarf Fortress. It's on paper, it's kind of fun, it's a lot of fun. I do game design for fun on the side, and that is about how you can't do everything, and so you are the whole class is a team, and you're trying to secure your system while things are kind of falling apart around you, and so that's kind of a cool thing. That's hopefully we can squeeze that in at the end of the semester, and so we've got some stuff going on there. They also do a case study where they are going. They study an open source project and write a paper about it, and this is, even if most of the students hate writing because, they're engineers, but what they do enjoy about it, and they do get a lot out of it, I have found in general, is they get to look at a real product. And so some products that people have done here are like Git or Node or Wireshark or Firefox or, and these are big open source projects that have had vulnerabilities, and they look at the vulnerabilities that they had. Kind of going back to my original experience of looking at Linux's vulnerabilities and kind of seeing myself in that. And so we kind of do a case study project around that. And they have to make a threat model of it too. Okay. So at this point, what I would like to do is I have a bunch of vulnerabilities of the day that we could cover. I also, on my laptop here, I typed out a bunch of random rants that I have throughout the semester. And so I could do one of these, most of them probably, or I could do some of these rants. So here are some of the titles of these rants. XML should be taken out to the shed and shot. JSON started with some really bad decisions. Psychomatic complexity is a mostly useless metric. Everyone just runs C most of the time, LOL. Stay dry. I am terrified of the Internet of Things. Or we could do any of those. What do you want to do?
I I feel like RC3 is becoming an increasingly hostile environment to JSON.
Really? Okay.
Good. I don't appreciate this blasphemy to JSON's good name.
Do you want to hear what I have to say about that? Because I think I have a good. But was there another one that you wanted to hear? What do you want to hear?
Yeah, Java reflection abuse.
Okay. All right. Java reflection abuse. JSON. Okay. Yep.
Was one about staying dry?
Okay. I can do that one too. Okay. Okay. Real quick. Raise your hand if you want Java reflection abuse.
Yeah.
Okay. Raise your hand if you want JSON. Okay. Everyone wants to hear JSON. And raise your hand if you want staying dry. Okay, all right. So first we're going to do JSON, then we'll do Java, then we'll do staying dry if we have time. So, wait, so I said first we'll do Java first? No, first we'll do JSON first. They're all the same, right? So, no, they're not. Okay, so JSON. Okay, so look, I don't have a problem with JSON structure of like a tree structure. Okay, we need that, right? We need structured data stuff, right? I mean, that's why we had XML. Although that needs to be taken out to the shed and shot. But the original creation of JSON started with a really bad decision, which was using it as a form of serialization. So the thing about JSON is that it actually is JavaScript, right? And so you can actually, to get the data structure, you can just say, execute this string as JavaScript, and you'll get a nice little data structure that is structured, okay? That phrase that I said of you should just execute this string as should have made you all cringe a little bit. That is a built-in injection vulnerability right there, right? And so what we did is we took, and so what used to happen is people used to say, well, you don't need a parser, you don't need to include things in JavaScript, you just execute it as JavaScript and it parses itself, man. But the thing is that like, you can have cross-site scripting really easily with that, right? So people started putting important data into it, and then you have JavaScript injection in there because that's literally you have a giant injection thing. So then we said, oh right, so now we need a JSON parser that is safe, which makes no sense because that was the original reason we had JSON in the first place, was to not have to have this. But then we just started making JSON parsers, and then now we just have this format. So. Now, I don't have a problem with the way it is now, but one of the problems that I have with people who don't know about this is that it was a really bad decision to say, let's just execute this as JavaScript. And I saw that. Like, I saw it. It was all over Stack Overflow. It was all over forum posts. Like, have you ever heard of this new thing? It's called JSON, and you just execute as JavaScript. You don't even need to import a parser, and that would get the green checkbox. So it must be right. And so that's, you know, nowadays what's interesting and weird is that we have JSON parsers everywhere, and they're safe, I think, usually. They try to be safe, and so now, you know, we just have this. So I don't mind where we are today, but it's interesting that it's this thing that started with the series of bad decisions. So I'm curious if you have a response to that.
I mean, like, realistically speaking, I just like JSON because I think it's a very concise, like, universal data format. I haven't even actually worked with it in JavaScript, so
there you go.
I'm always working via parsers.
And that's the thing, is that like then it just it grows beyond what it is, right? It just becomes, people don't even realize that the J in JSON stands for JavaScript, and it was just JavaScript object notation because JavaScript didn't even have objects, really. And then it did. Now it's really confusing. Okay, next, Java reflection abuse. Okay, I'm going to boost the font real quick. Zoom in, there we go. So Control plus, or not Control plus, Control Shift plus. There we go. Okay. All right, now I'm just going to SSH in front of all of you because, you know, that's secure. Yeah, fine. It's been a while since I've actually used this password because I usually use keys. Oh, good, that worked. Okay.
Is it Hunter 2?
No, it is not. Or is it? I don't know.
It's Hunter 3.
You type it out right now and show up the stars.
No, I would not. Nice try. I am immune to a little bit of social engineering. So, I'm immune to at least that much. I'm immune to at least that much. So you can actually download this. This is actually a pretty easy one. Okay, so when you learned about Java, so I'm going to quiz you all on Java. I know I'm going to take you back to your CS2 days, and I know that some of you have PTSD from that. But so if I have an object and I have a field, I think is what they call them, or something that is not in a function, it's outside of a function, but in the class in an instance, and I want to make sure that nobody else outside of my class can access it. What do I use? What keyword do I use? Private. So you would think that so let me get this straight. If I am another object, I cannot access the private fields of another object.
Potentially, supposedly, not necessarily.
You're not supposed to, but you can. And so what is interesting about this is that you actually can do this. Java allows you to get around it, and it is unholy. It is weird. And so I'm going to show this to you, and there actually is a very easy mitigation for this, and it's called the Java Security Manager, and it's a thing that nobody ever uses, but it's actually something that is not all that hard to use, and it's pretty cool, but again, it's turned off by default, so most people don't use it. So let me show you what I mean. So the situation that I'm talking about is actually kind of a rare situation, but it does happen. It's what I'm going to call an untrusted API situation, and that means that you have Java that's running, and you are running untrusted code inside of your virtual machine. And when I say virtual machine, I actually mean the Java interpreter. Virtual machine used to actually mean something, and then we created virtualization. So now we have two meanings of the word virtual machine. But so now you have I have secrets inside of my object that I don't want anybody else to access. So and so I make it private. And you might be thinking, why are you doing this in the first place? But this is what we call a plug-in architecture. And this is what we call user-generated content. This is what we call mods, right? So if you want your architecture to be moddable, if you want user-generated content, which is a huge business and a huge thing, you are going to have to, at some point, execute code you don't trust next to your own. So it's actually pretty common. So let's say I have API connection.java. And maybe I will shrink this down just a little bit. Okay, so I have a class here, API connection.java, and I have a private string token. That was a secret. I also have, so I have the public do something, and then I check it against the password, and then I have the private do something secret. Okay, so I have a private method and a private class. And so another class should not be able to access this, but it can through reflection abuse. So here's what it looks like. So this would be an evil plugin. And so what I do is I create a new object, and then I do line 33. So first of all, I'm just going to try to do it where I just, try and guess and it doesn't work. Okay. But then what I'm going to do is I'm going to say, here's the object, .getClass, .getDeclared fields. Did you know that this existed? There is a class called class, right? And it creates an object a data structure that represents the metadata around your object. Now, what's interesting is that Java over many of the years has iterated a lot on what things are allowed to be kept secret and what things are not. But okay, let's keep on going. So what's the name of the field? Can I get the name of the field? Yep, I get the name of the field. And then what you do is, and you can see lines 36 to 40, is I say field.set accessible to true. So accessible is set to false by default because it's private. But you can just undo that with set accessible to true. I know, isn't this unholy? Like, this feels so dirty. This feels so dirty. Okay, so then you're going to get the field. And then essentially, just to kind of speed this up a little bit, you can get the declared methods. You can invoke those declared methods with whatever you want. Again, you have to use the set accessible to true. Now, you can already see the solution to this is right there on lines 55 to 57, which is catching a security exception. So you can see that this is, you know, this is turned off by default, but if you turn it on, the security manager will lock all this stuff down, and then you can start opening it up selectively. So yeah, that's Java reflection views. Places. So there are a couple of things to note here. Number one, if you are running untrusted code alongside of yours, you got to run your security manager. The number one place where you run the security manager are in browsers. Anytime you see an applet, or I mean, I know applets aren't as in fashion anymore, but if you see Java in a website, it has to run inside the security manager. If you want to control like what the Java program does, like if you don't want it to make a network call, or if you want it to only be able to access a certain host, you can configure that in the security manager. If you want to limit what files it can open or close, or what environment variables it has access to, you can configure all of that. So we have a whole activity devoted to that in that class. So there you go. That's Java reflection views. I'll bet you didn't know you could do that. Before you start hating on Java, you need to understand that all computers suck. And so one of the things, and it's all about trade-offs, right? So one of the things that I like about Java is that it has the security manager where you can actually mitigate this. The only other languages that let you do this are the native ones that like C and C++. All the other languages don't have a viable security manager. PHP tried to have one and they ditched it. Python has not been able to do one. Ruby kind of has one, but it's not great and it's not widely adopted. JavaScript doesn't have this. You know, all the other programming languages have not succeeded at having a security manager that allows this kind of thing, that allows you to lock down untrusted API stuff. But Java does. And that's something that I think is interesting from a case study perspective. The whole PHP abandoning it thing, oh, PHP is so broken, don't even use that thing. Yeah, so that's that. Okay, that's Java reflection abuse. And just to show you that my code is not just code, I can actually run make, and it will actually like, hey, look, that was a secret, and then I can actually execute stuff. So you can actually, just so you trust it. The third one was staying dry, right? So the best piece of design advice that I have ever heard, if I could boil all of software design down to one sentence, most software designers would be like, that's not fair. But if I were to bring it down to one piece of advice, it would be to stay dry, which is don't repeat yourself. So don't repeat yourself is a heuristic that you can use as you're developing software to, if you find yourself copying and pasting code, then you find yourself kind of copy, paste, edit just a little bit, and it's a little bit different than the other things, then you probably have a design problem. You probably have code that can be extracted into something else. In general, the heuristic that I use is, okay, copying and pasting once is fine, but on the third time, on the third copy, I definitely have a problem. And so I need to rethink the way that I'm doing this. One of the places that you see dry happen in secure software is you see a lot of repeated mistakes. So one example that I just told it in class was there was a system. There was an open source system, I can't remember what it was, but it was one that worked with a lot of files. And they had a lot of path traversal vulnerabilities. And so they had problems with canonicalization. They had problems with path traversals. And so they fixed it in one place, and then another vulnerability cropped up, and they were like, oh, fix it in this other place. Just fix it like you fixed it over here. And then they did that 4 or 5 more times, and you had 10 different ad hoc fixes to it. And eventually they went, let's create a utility method to do this all in one place. And then they iterated on that because there were places where their mitigation was pretty good here and not so great there. And if they had just stayed dry, if they stopped repeating themselves and extracted that functionality into one place, then they could secure it in one place and they could be secure throughout the rest of the system. So, that's what I mean by stay dry. That one is an example of good software engineering advice that also happens to be good, secure software engineering advice. Yeah. Okay, so we're up to 120. Let me just kind of ask, do you want me to do a few more of these? Do you want to do something practical where you guys were, I don't know, I didn't have any challenges for you today, but if you are welcome to try and get some of my examples to work, we'll send out that link. What do you want? Yeah.
Why should XML be taken out the shed?
Thank you so much. I must have really wanted to talk about this today. So XML is, so I love XML the way that we've talked about JSON here, right? We need to be able to structure data. I'm not against structuring data. And in fact, if XML were just, the open tag, close tag, and just structuring data, if that's all XML was, I would like it. I would have no problem with it. And that is probably what you think XML is too. Unfortunately, XML is not that. It is a whole lot more than that. XML is the, I think for me, the poster child of feature creep. So feature creep is a problem that, as software engineers talk about, where we have this thing and we want just one more feature and then just one more feature and then one more feature, and we tack on all of these extra features to try and make our lives easy, and then what we have is something that looks simple but it's a lot more complicated. So one example of this is XML Embedded DTDs. So here's an example of this, and then I can tell you a little bit more about XML in general. So XML is it's structured tags. It's, looks like HTML. You know that. And one of the things that you want to do with XML is you want to validate its structure. You want to make sure that the structure matches what you think it should match. So like this tag should only have one parent, or this tag should only have one child, or something like that. And you want to encode all of those rules. There are two main ways to do that in XML. There is XML schemas, which is XML validation written in XML. It is god-awful to work with. And I did most of a co-op once doing XML schemas, and that was awful. And then the other one, which is a little bit older, but is still widely used, are document type definitions, DTDs. And document type definitions are this little language of how do you specify things, specify the structure of an XML file. So far, so good. If I'm talking about like validating the structure of a file, as security people, you should like that, right? Like, we want to make sure that this follows strict guidelines so that we know the exact input that's coming in. You guys should be in favor of input validation, and so am I. The problem is when you can embed a DTD inside of its own file. Why in God's name would you ever do that? That is like saying, I'm going to go to the customs agency with my little moleskin notebook saying, hey, here's my passport from Andy Landia, and they'll go, I've never heard of that. And I'll go, well, there are instructions and a map in the passport. You should just trust it. And they go, oh, well, I trust all of the maps inside passports that are untrusted, so I'm just going to use that to validate the legitimacy of your passport. You can pass. That makes no sense. You shouldn't be able to embed the validation scheme in the payload itself. That's crazy. You're trusting the person. You're trusting the source. You shouldn't trust the source. So here's my example. So suppose I have a file called secret.txt, which is, so you might be thinking that, oh, XML is just data, right? Well, it can't possibly access the underlying file system. Well, a lot of times it can. Here is one in malicious.xml. So what I have here is a document type definition at the top. I've got, and I called it malicious DTD, although you probably shouldn't name your exploits like that if you want, but okay. That probably would trip an IDS somewhere, but and then what I do is I define an entity. Now you might be going, I'm an expert on XML. What the heck is an entity? That's right, you're not an expert on XML. It is a much bigger thing. If there is a book on XML, the fact that we have books on XML, the fact that we have had classes on XML just goes, it's too big, it's too much for what we use it for. What you can do is an entity is where you define like a little primitive. So in this case, I defined it as the word file, although I could call it whatever I wanted, and then I use it as ampersand file semicolon. And what I did is I gave it the system thing. Yeah, that's right, there's a system custom entity thing that allows you to access underlying files in the system. So instead of doing secret.txt, I would do like etc shadow or something like that in there, right? I mean, like, why not? You can do this. So if there is ever a place where you can upload an XML file that has DTDs, embedded DTDs turned on, which most of those parsers have them turned on by default because we want hello worlds to work all the time, all that stuff is usually turned on by default, and so you can have an exploit there. You can have a path traversal vulnerability, or actually, if you're good enough, I think you can do arbitrary code execution. The way that you fix this is actually quite simple. Well, there's an underlying problem here. I mean, so first of all, don't trust technologies that have suffered from feature creep. Like, I think that's a broad. I joke about it laughingly in a way because I hope that you remember it, but I want you to remember that there are some technologies that undergo too much feature creep, and it's time to take them out to the shed and shoot them. But then there are other times, but then also, like, why would you allow yourself to be validated? Why would you put your validation scheme inside the file? Why should that be part of the whole specification? That's crazy. A more popular one that you might have seen before are XML bombs. XML bombs are not that common anymore. We've mostly mitigated them. Most XML parsers fix this by default. But they're fun anyway, so why not? I think they were originally called a ha-ha bomb, because instead of doing A, you do ha. And then what you do is you define A as ha, and then B as 2 A's, C as 2 B's, and so on. And in fact, just putting 2 in there is not very much. You can put a whole bunch, then the exponent goes way up. But what you've got then is if you do Z, then Z references Y, which is 2 X's, which is 2 W's, and so on. So what you get is a file that is small, but then when you try to parse it, it takes up gigabytes of memory. It can take up any amount of arbitrary memory you want to parse. That fills up, the system starts swapping. Maybe the swap file is not managed. The swap file then takes up the whole hard drive. You've got a whole server that's bricked, all from one XML file that you've uploaded. That's what a bomb is. Now, nowadays, a lot of parsers are smart enough to go like, whoa, like, you don't need to expand this many entities. So it just kind of cuts it off after a while. You do have other compression bombs, though. Of every compression format has had some sort of bomb in it where somebody uses the compression format. And I mean like all of them, like zip, ping, they've all had a problem at one point or another where somebody figures out how to construct data and maybe even construct a compressed file that when decompressed is astronomically big compared to the small one. And so these compression bombs are another kind of vulnerability to be careful of, especially since a lot of times compression is applied to untrusted data. Usually decompressing data is like the first line of defense, not defense, but the first line on the stack. So it's like you compress all your HTTP data or you compress an image file or something. And so that's another thing to be careful of. So there you go, you got 2 vulnerabilities of the day in one. So you're ready to and the thing is, like, you actually can use XML, just like JSON, you can use it safely. You just have to do more work to use it safely. That's the dumb thing about it. Anything else?
Any questions?
Yeah.
What do you think one of the upcoming milestones in secure software is going to be?
Quantum computing.
How come?
Well, I don't know enough about cryptography, but the people that I know who are into cryptography are freaking out about quantum computing.
So I mean more of like, what's going to be the next milestone in writing, creating secure
Ah.
software?
Okay. Yes. Let's make it more positive. I mean, I alluded to this earlier. I would love to see secure elections. I would love to see our elections be much more secure. It's so what's been so aggravating is that even before I cared about security, back when I was in middle school and high school and we were talking about the Clinton administration, security experts would go to these conferences like DEF CON and Black Hat or whatever the ones they were in the 90s, and they would take these voting machines and they would break into them and they would show that the voting machines were insecure, and they've done it every year for 20-some plus years, and our country has never really cared about the security of our elections, the cybersecurity of our elections. And it's a real shame that we've gotten ourselves into a pickle today. So I would love, and I don't know what it's going to be, but I would love to see something. I'm convinced that like the blockchain technology could make for an auditable voting record. But I don't know what it looks like. I don't know what it is. I mean, otherwise, if I did, I wouldn't be here. But yeah. So that's. I think that if we can, for me, that would be a big deal. Is to see secure voting. Voting that I'm convinced is secure.
What would need to happen for that to occur? What milestones do we need to accomplish before you would consider that we have what you would say is secure voting?
Where we can actually do audits regularly. We don't really audit most of our elections now anyway, and when we do, it's very resource intensive, and it would be great if we had an automatic audit. If it was some sort of blockchain that everyone in the world could see, something that was more transparent. The milestones to get there, though, is well, I mean, I think the improved trust in cryptocurrency, I think, has gotten there. If blockchains are the way to fix elections, and I don't know if they are, but if it is, we're definitely making really good advancements in cryptocurrency and blockchain. Yeah, interesting question. I would also just love to see fewer vulnerabilities out there. I don't want my discipline to be in the news so much, so that's a negative thing. But other questions? Yeah. Ah, 331 requires SWEN 261 and a co-op. Now, the and a co-op thing is not a big deal for CSEC majors because you guys can start taking co-ops after your freshman year. That's not true about SWEN majors. I will say there are a couple of situations where I allowed people in without taking 261, and I regretted doing that because SWEN 261, Intro to Software Engineering, even though, yeah, I know it can be a problem course, it can be a challenging course, but it really teaches you what software engineering is, and the language of it is in that. That being said, we do have the cluster in secure software engineering, and I would say 331 is like the key course in doing that cluster if you want to do that in the major. But other than that, we used to have higher prerequisites for 331, and I lowered the prerequisites and redesigned the course to be lower so that CSEC majors could take it. So, okay, thank you.
Thank you. Thank you for doing that presentation. Yeah, I'm in the class, as you guys have already heard. I think it's awesome. Probably one of my favorite classes that I've ever had all of my school years. Where's the presentation? Is it?
Oh,
we still have it.
Closed it out.
Oh, okay. I'll just talk about it. Yes.
Sorry, I'm so sorry. I'm a terrible security person. I need to log out of my SSH session.
What are you talking about?
What's that?
Okay.
Yeah, I was gonna say, yeah, okay, go ahead. I am not gonna do that at RC3.
Anyway, so as you guys all know, HackerOne is one of our sponsors. So RC3 is doing a bug bounty challenge, if you go on HackerOne and you happen to find a bug bounty and you write a report and you submit it, we will give you points on the scoreboard based on the severity of your challenge. Send those to Joel because he'll probably grade them anyway. But yeah, cool. Yeah, but thank you again for that talk. I think that was really great. One more round of applause. Yeah, we are probably over time for, we're not supposed to be here anymore, so we're all gonna head upstairs to the Sec Lab. Cool, I'll see you guys out there.